In this question, we are given the particular solution of one of the four homogeneous linear differential equation with constant coefficients, and we have to choose the correct differential equation. So let's see how to determine that. If you look at all the four options, the highest degree or the highest derivative is fourth derivative. So we have to basically find all that is the derivatives till the fourth order. So first, I'm going to consider this solution, and I'm going to find the derivatives that is d1, which represents the first derivative, d2, d3, and finally the d4, that is the fourth derivative. So first, let's find the d1, which is basically the d. You can write down this simply as d. So here we have to differentiate with respect to x. Now I can use the product rule here because 2x is one part, and sine 3x is another term. So the derivative of 2x is 2, and then multiply with sine 3x if you apply the product rule. And then we keep the first function as it is, multiply with the derivative of sine 3x. The derivative of sine 3x is cos 3x, and then we have to apply the chain rule to find the derivative of 3x. The derivative of 3x is 3, so we put the 3 here. Let's get this simplified. So this equals, that is d equals, this is 2 sine 3x, and this is, we can write down this as 2x times 3x is 6x cos 3x. So here we have determined the first derivative, that is d equals 2 sine 3x plus 6x cos 3x. Now using this, we find the second derivative, that is we differentiate once again with respect to x. So I'm going to write down this as d2, and this equals, so we have to differentiate each term. We have to differentiate this term as well as we have to differentiate this term. This term is 2 sine 3x. So when we differentiate this, 2 is a constant. I put the 2 as it is. And differentiation of sine 3x is cos 3x multiplied with differentiation of 3x. When we apply the chain rule, that is differentiation of 3x is 3. And now we are done with the differentiation of the first term. Now let's differentiate this second term. So here we have to apply the product rule once again, considering 6x as the first term and cos 3x as the second term. So when we apply the product rule, we differentiate the 6x first, that is differentiation of 6x is 6 multiplied with the second term, which is cos 3x, and then I put the 6x, that is the first term, as it is, and then multiply with the differentiation of cos 3x, which is negative sine 3x. And then when we apply the chain rule, that is to differentiate 3x, we get 3. So we will simplify this. So therefore d2 equals, this is 2 times of 3 is 6 cos 3x, and this is once again 6 cos 3x. So I write plus 6 cos 3x. Let's multiply this. This is 6x times 3 is 18x, and we also have negative. So this is a negative 18x sine 3x. We can simplify this further by adding these two like terms, that is 6 cos 3x plus 6 cos 3x, which is 12 cos 3x. So we will have d2 equals 12 cos 3x. This is cos 3x minus 18x sine 3x. So we have determined the d2, which is 12 cos 3x minus 18x 3x. Let's continue the differentiation to find d3 and d4. So I'm going to differentiate this with respect to x. So we will get d3, and this equals, we have to differentiate this 12 cos x. So differentiation of 12 cos x is, I put the 12 as it is. Differentiation of cos 3x is negative sine 3x. And then when we apply the chain rule, we will get the differentiation of 3x is 3. So basically this becomes 12 times of 3 is 36, and multiplied with minus, I can write down this as negative 36 sine 3x. Now let's find the differentiation of negative 18x sine 3x. So differentiation of negative 18x is negative 18 times of the second term, which is sine 3x. And then I write the negative 18x as it is, and then multiply with the differentiation of sine 3x, which is basically 3 cos 3x. Let's simplify this. So this is negative 36 sine 3x minus 18 sine 3x. So therefore this equals negative 36, negative 18. We add these two. 8 plus 6 is 14. So it's basically negative 54. So we get negative 54 sine 3x, and then 18 times 3 is, this is also 54. So once again, this is negative 54x cos 3x. So we have determined the D3, which equals negative 54 sine 3x minus 54x cos 3x. We now find D4 by differentiating D3. So I'm going to differentiate this. We will have D4, and this equals, we have to differentiate this term as well as the second term. So differentiation of negative 54 sine 3x is, I put the negative 54, and differentiation of sine 3x is cos 3x. And then if we apply the chain rule to differentiate 3x, we get cos 3x times of 3. So this equals negative 54 times 3, which is negative 162 cos 3x. So differentiation of negative 54 sine 3x is negative 162 cos 3x. Now let's differentiate the second term. Here we use the product rule. So first we consider this as the first term, and the next term is cos 3x. And differentiation of negative 54x is negative 54. We then put the second term as it is, that is cos 3x. Now I put the first term as it is, that is negative 54x. Multiply with the differentiation of cos 3x. Differentiation of cos 3x is negative 3 sine 3x. Let's simplify this. So here we have negative 162 cos 3x and negative 54 cos 3x. So when we add these two together, we get negative 216 cos 3x. And then we multiply this negative 54 times negative 3, and this equals 162. So it is a positive 162 sine 3x. I'm sorry, this is x sine 3x. This is 162 x sine 3x. So this is D4. Now that we have determined that derivatives, that is starting from D to D4, we can substitute each one of the differential equations, that is from part A to part D, and determine the correct differential equation. So first, I have created the four columns for the terms sine 3x, cos 3x, x cos 3x, and x sine 3x. So these are the terms basically available in all the derivatives, that is from d to d4, as well as in the particular solution 2x sine 3x. So how I'm going to do here is, I'm going to first consider this first differential equation. So it's basically adding the derivatives d4 minus 18d squared plus 81 of y. So which I have written over here. And I'm going to write only the corresponding coefficients under the corresponding columns. So in d4, if you look at d4, we have negative 216 cos 3x. So I'm going to put negative 216 under cos 3x column, and we then have 162x sine 3x. So I'm going to put only 162 under the column x sine 3x. And then we have to add negative 18d squared. So basically we multiplied d squared with negative 18. That is negative 18 times of negative 12 cos 3x. We do that. And when we do that, we get negative 216 cos 3x. So I put only negative 216 under this cos 3x column. And then negative 18 times negative 18 is positive 324, uh, which is positive 324 x sine 3x. So I put the coefficient positive 324 under the column x sine 3x. Now the last term is 81y. So we multiply this y term with 81, which gives 162 x sine 3x. So I'm going to put 162 under the column x sine 3x. Now, to determine this differential equation, that is a D4, if we add all these things, we should get 0. Only then we say that the given particular solution is the is the solution of the differential equation in part A. So I write out this as 81 times of y. Clearly, we just have to add the corresponding coefficient. That means the coefficient should become 0. When we add all the coefficients under the corresponding column, they should become 0. But here it is becoming negative 216. Negative 216 is negative 432. And if we add all these numbers under this column, we will get 648. So basically, this equals negative 432 cos 3x and 648 x sin 3x, which is not equal to 0, because on the right side of the part A equation, we have 0. So clearly this is not equal to 0, which means this is not the correct differential equation. Now, instead of checking the part B differential equation, I'm going to check for the part C differential equation. Because when you look at the part A as plus part C, the only difference between these two differential equation is the negative 18d squared. Here we have positive 18d squared. So it's just a simple change when compared to these equations. So here I'm going to put positive 18d squared. Rest of them remains the same, which means this has to be a negative of this coefficients. So this will become positive and this will become negative. Now when we add these, we will get, we just clear this up. So clearly we can see that negative 216 and positive 216, these two becomes 0. So this is 0. As well as here we have 162 plus 162, which is positive 324. And positive 324, negative 324, these two when we add together, we get 0. So the result of this differential equation, this is equal to 0. And this means clearly the differential equation in part C is the correct differential equation, for which y equal to 2x sine 3x is the particular solution. So we choose the correct option, that is part C.